Okay, in this section, we will learn vector functions and space curve. Before we learn what is a vector, okay, like say A is a vector with 3 components, A2 and A3. This is a constant vector. Today we are going to learn function vectors. Say R's of t. Everything is the same, but now it's a function. Each component is a function. Ft, G's of t, and h of t. T there can take different values. For example, from negative infinity to positive infinity. So, what's the graph of that? Now this really is x, here is y, here is z. So for given t, you plug in there, you can find x, y, z. So you find a point in the space. For different t, you find a different point. You connect those, you got a curve in the space. Okay. So for given t, you plug in there, you can say you got a point, or you can say you got this. You got a triple. This triple could mean a point, also could means a vector. So that is origin end up with that. This vector will be your R's of t. For example, special case, R's of t. Now if my ft here is a linear function, 1 plus t, and g's of t there is a minus t, and h of t is 5 plus 2t. Now this is special vector function. So what's the graph of that? This is x, here's y. X can be found by using formula 1 plus t. Y can be found by minus t. And z, the formula to calculate z is 5 plus 2t. 2t. Do you think this formula looks familiar? In fact, this is a parametric equation for straight line. Okay. So in the other words, the graph of this vector function is a line. Okay. What is a line? Special curve. Okay. In general, the vector function like this is a space curve. Okay, it's a curve in the space. And a straight line is a special curve. Okay. Line is a curve. Okay, what we can say about this line? So this vector function is a line. Okay, this line will contain a point, what? P0 will be like 1, 0, and 5, right? And also contain this point 1, 0, and 5, and a parallel with a vector n. What is n here? N could be 1, minus 1, and 2. So this vector function gives you straight line. This line parallel with a vector n, 1, minus 1, and 2. Now, especially if your vector function only have like 2 components. For example, like this. What's the graph of that? Now you only have x and y here, so you still get a curve, but this curve is a plane curve. It's a curve on the plane. If you have 3 components, you got a curve in the space. Okay, for example, if you let t equal to 0, cosine 0 give you 1, sine 0 give you 0, so you got this point. T equal to 0, you got this point 1 here. If t equal to pi over 2, cosine pi over 2 give you 0, sine pi over 2 give you 1. Then you got this point. When t equal to pi, you will get this point, and 3 pi over 2, you got this point. Okay. So what kind of curve is this? We only know the 4 points. Okay, this is a plane curve. In other words, x is calculated by cosine t, y is calculated by sine t. T can be any number. Okay. So, for this simple curve, we can take square on both sides of the equation. So x squared plus y squared will give you, because x squared is cosine squared t, y squared is sine squared t. So this will give you 1. Therefore, the curve, plane curve described by this parametric equation really can be written by equation like that. We know this one give you a circle. Okay. So for the plane curve, we have another way to describe it. Remember, y equal to fx. So if your plane curve is given by parametric equation like this, you try to get rid of t, you end up with the equation between x and y. Then we know better to describe plane curve by this way. Okay, now let's look at another example. This example, we want to find vector function or vector equation. Doesn't matter. Vector equation and parametric equation. For the line segment between the point P and the point Q. P there is 1, 0, and 1. Q here is 2, 3, and 1. So we only want to the part of the line determined by the P and the Q. We only want to, here's the P and here's the Q. We only want to part of this line in between P and the Q. Okay, so first of all, let's find the equation of line determined by point P and Q. Remember, how do we find the equation of line? We need to know the P0. What is P0? Any point on the line will be qualified for the P0. So you can either use point P or point Q. Doesn't matter. We use point P. Okay. Okay. Next thing is find n. What is n? N is any vector your line parallel with. Okay. Obviously, the vector from P to Q will do it, which is P to Q. Give you this vector. So use the coordinates of Q, subtract the coordinates of P. So 2 minus 1, 3 minus 0, 1 minus 1. Give you 1, 3, 0. So, then we can find the parametric equation. Remember, x naught plus at, y naught plus bt, z naught plus ct. Okay. For this case, my x naught is 1, a is 1, so plus t, y there is y naught, which is 0, plus b is 3, 3t, z is z naught, which is 1, plus 0 times t. So this will be your parametric equation. Let me simplify this. 1 plus t, y equal to 3t, z equal to 1. So we find the parametric equation for this line, for the whole thing. If t from negative infinity to positive infinity, they give you all the points. Now, if you only want the point between P and Q, now let's see. 1t equals 0. 1t equals 0, you got a point. Your x will be 1, y is 0, z is 1, right? That's exactly our point P. When t equal to 1, you get a point 2, t equal to 1, your y is 3. Your z is still 1, okay? There's no t, so z is always 1. That's exactly the point Q, okay? So, if you let your t between 0 and 1, they give you all the points in this line segment between P and Q. Okay, so this is a parametric equation. Okay. What do they mean vector equation? They mean this. You just replace x there by 1 plus t, y by 3t, z by 1, and t here is between 0 and 1. This they call the vector equation. If you restrict your t is between 0 and 1, they give you the points between P and Q on the line.